Bismillahirrahmanirrahim. Assalamu alaikum. Um, Hello, students. How are you? I hope you are doing well. Today we will learn about mathematics of class intermediate and chapter number 2. So, using this book, and the question is question number 3, find the limit of the following sequences whose nth terms are given. So in previous question number 2, we used to find the limits of sequences where sequences were given, and we have to find the nth term and then their general term. But in this case, nth term and then the limit of that sequence. But in this case, we have been given this nth term or general term, and we have to find out the limit of that sequence. So how to find out the limit of this sequence or this function or this general term? It's a general term, it's a formula for a sequence, and we have to find out the limit of that sequence, that if you increase the value of n up to infinity, what will be the limit, what will be the end point of what will be the result of that sequence. At the end, what picture will that sequence look like? So that's what we are going to find out in this question. So the procedure is solution, taking limit on both sides. So on both sides, okay. So what we will do, actually, we will write limit. If it is n, we will write n tends to infinity. If it is x, we will write x, or whatever the variable is, we will write that variable here. Of an is equal to limit n tends to infinity of this whole 1 plus 5n over 7n. It's a simple question. Now, what is wrong with this? Why we are not directly putting that infinity in this function? It's because if you write infinity here, 1 plus 5 n times infinity, so 5 times infinity, you will get infinity again, and here is another infinity, so infinity over infinity, that will make more problems, that will create more problems, that will become again infinity, so or undefined. So we have to get rid of this n here in some way. So what we have to do, we will take n common and cancel it. So how to take n common? We will write kind of multiply with this n with this and this, or multiply with 1 over n with both the values, and hence we will cancel it. But the procedure, the simplest way is used to say that take common from both the values. So if we take common n from this value, this has no n value, so you write n in this place, and then it has n which is common. Now it will become 5 here, and in this problem we have n and then 7. So now n and n will be cancelled. We are left with 1 over n plus 5 upon 7. Now you can now you can apply the limit. Applying the limit, okay. So apply the limit means you have to write the infinity in place of this. So that way, that is 1 over infinity plus 5 over 7, and we know that 1 over infinity is equal to 0. Now Why it is 0? Because when you divide 1 into infinitely many parts, the answer you will get, which will be very small, possibly like equal to 0. Hence 1 over infinity or any number over infinity becomes 0. So we will write 0 in place of this, and then we add 5 over 7. So the final result is of 5 over 7. Hence the answer of our question, limit n tends to infinity of an, is 5 over 7. All right, I hope you understood this question. So now we have next problem, which I'm going to solve here. The next problem is that says number 2. Okay, so which is number 2. It's an is equal to 3n minus 1, and then n power 4 minus n over n square plus 5 n cube minus 7. This is the new question, the general term. We have to find out the limit. So we write solution, taking limit on both sides. Okay, so we write limit n tends to infinity of an, and then limit n tends to infinity of all this stuff, whatever it is. So it will be okay to multiply all these values with these two brackets will be multiplied. So 3n times n power 4 will be 3n power 5, and then 3 into minus n, this will be 3n square minus n power 4 and plus n. So this is all over in the numerator, and now we will multiply this with the denominator n square times n cube is n5, and then minus 7n square, then plus 5n cube, and minus 35. So we will simplify if there is any need to simplify the terms, add or subtract. I don't find anything. This will 3n power 5 minus 3 minus n power 4 minus 3n square plus n, and then we have n power 5 minus bulky plus 5n cube minus 7n square and minus 35. So now the procedure is to take common, and we will take the common or the variable which is with highest power, which is n power 5. So I will write limit n tends to infinity, n power 5 is common, so I will have 3 minus, now n5 is common. This has 4, but it needs one n more, so we write that n in denominator, and minus 3, this has n square, we need 3 more, so we write n cube, and then plus it has 1 and we need n power 5, we will write 1 and 4. In the same way we have n5, which is common from this bracket, n5, I guess, n5, so we have 1 and then 5, n cube we have 5 over n square, then minus 7 n square, and we need 3 more, so it's n 3 minus 35 over n power 5. So n5 has been cancelled. Now applying the limit, uh, applying the limit. So when you apply the limit n tends to infinity, that means you have to write infinity in place of all these values. We have 3 minus 1 over infinity minus 3 over infinity cube or infinity square, whatever. This will again be infinity plus 1 over infinity, and we have 1 plus 5 over infinity minus 7 over infinity minus 35 over infinity, and hence we have this is 3 minus this will become 0, because we know that 1 over infinity is 0. So we have minus 0, and then another minus 0, then plus 0, and divided by 1 plus 0 minus 0, and then minus 0. So we are left with 3, and that is the answer. So limit n tends to infinity of an is equal to 3. This one is the answer for you. I hope you understood this. And now we will solve the third part of this question, this problem. So third part is this one. We will solve this one. I guess you see this is clear, possibly. Okay, so this is third part, and which says find out the limit. Third part, which says find out the limit of the sequence an is equal to n plus 1 factorial over n factorial minus n plus 1 factorial. All right. So how we can simplify this? You will write like applying the limit, or sorry, taking the limit solution, taking the limit on both sides, taking the limit on both sides. Okay. So this will be limit n tends to infinity of an is equal to limit n tends to infinity of all this stuff n plus 1 factorial over n factorial minus n plus 1 factorial. Now we have n plus 1 factorial. Now if we open this, because 5 factorial or 4 factorial or 3 factorial we write, which is, for example, if there is 5 factorial we write is equal to 5 times 4 times 3 times 2 times 1 and then factorial. In the same way, it is like decreasing. One is decreasing from every term. So 5 is decreased by 1, which is 4, and 4 is decreased by 1, which is 3, and then 2, and then 1. Hence, if we have n factorial, this will be equal to n times 1 decreased, which is n minus 1, and then n minus 2, and n minus 3, and so on. So this will goes on and on. All right. So if we have n plus 1 factorial, how we can write this n plus 1 factorial? This will become n plus 1 times, now n plus 1 minus 1. So you will get this cancelled, and then n plus 1 minus 2, and so on. You have n plus 1 times n times n minus 1 and factorial. So this is all about the opening of this statement. So we can use these results to kind of simplify this question. Also, limit n tends to infinity, and then we will write limit n tends to infinity of a, and sorry, this will become, if we open this statement, we have n plus 1 times n, all right, times n factorial. So this is all about this is statement, and then from here n factorial minus n plus 1. The next term will be n, and then we have factorial here. So now limit n tends to infinity. If we take n factorial as a common, right? So n factorial as a common, so we have n factorial, and then n plus 1 over, from here it's n factorial common, we have 1 minus bracket n plus 1, and this is, n factorial has been cancelled. Limit n tends to infinity. Now we are left with n plus 1 and upon 1 minus n and minus 1. This plus 1 minus 1 has been cancelled. So we have limit n tends to infinity of n plus 1 over minus n. So this minus n can be written here. So limit n tends to infinity, I can write this as uh, minus n minus 1 over n. Alright, so this can be written further as limit n tends to infinity of minus n over n and minus 1 over n. This can be simplified as limit n tends to infinity minus 1 over n. Now if I apply the limit, applying the limit, we have, this will become minus 1 over infinity. So minus 1 over infinity or plus 1 over infinity, in any case it is 0, minus 1 minus 0, which is equal to minus 1. Hence the limit n tends to infinity of an is equal to minus 1. This is the all about question number 3 of class intermediate. I hope you understood the points or the way or the method. If there is any possible correction, kindly write me in your comments, and wish you good luck. Thank you very much for patience. Goodbye.